Morning. I'm honored to be here, present some concept involved with so-called advancing innovative technology. Actually, it's AI technology. Okay, everybody's there. You know, in past 1 year, AI stuff like a big windy brought everybody. So now everybody will start with two things happen. Everybody see this open AI. The other is big server, AI server from NVIDIA. So which put together, now everybody can start their own AI stuff. However, this this is a portion of AI. What happened is this AI called data AI processing. Everybody can put your data into the server. They will collect all the data and answer your question. So now everybody has a tool. Think about the evolution of the computer's processing. When you start with about 20 years ago, you have a Google, so you can search any data in Google. You look at very advanced. Now, change to AI. You can search the whole answer, including what you're asking for. Google just answer what you're asking. I want to know this story. I want to the street. I know anything. It's a single spot you ask. Now we talk about entire theory. I just read a book talk about how medicine involved with OpenAI or GDR4. So it's going to change our life in certain way, especially when you're doing the data processing. This is what happens. However, there is another AI, which means the hardware AI will impact on your daily life, which means that a lot of instrument, a lot of like a toy, a lot of things will become so AI. For example, after children have some toy or some doll, this one will be definitely belong to him. It's not share to anybody. You can use AI to talk this, or he only listen to you, doesn't listen to anybody, and even your mom, they don't care. This kind of thing going to happen. So what happen is when you have this door, the kids will feel this is me belonging. So if we don't have a sister, I have a door, I have someone I can pray with. This is going to happen. But this kind of AI is different from data formation AI. It's your personal use. Okay, it's going to happen. So let's talk about how these things it's oh, how things going on right now uh, in computer prospect, how that affect us. First of all, alarming trend, raise cost of semiconductor. In order to do this AI processing stuff, the big company TSMC, they have to move to 3 nanometer, 2 nanometer. That's very expensive. Okay, when you're looking the NVIDIA chip making the servo, that servo is so expensive. It's maybe 10 times, 100 times more than the servo that you are using right now. So everybody have paid a lot of money for that kind of processing. You know why? Because you have such a flow of data, the big data to coming into the computing, you need a lot of big computing power, processing faster, makes everything go happen. Secondly, performance is money. Okay, means that when you have a, NVIDIA stuff, you use the NVIDIA give us several different pricing. You want a better performance, you pay more money. That's very simple because it costs to make. Okay, money, bandwidth, of performance. Okay. This another most interesting thing is happen is that normally when we use your notebook, your desktop, or even your handset, you have MCU or CPU, whatever. The 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 CPU clock no more than 5 gig. You cannot do anything beyond that because you go there it burn out. It's so the heat a lot. So we stick with 5 gig cycle. Now what to do if we stick with the 5 gig cycle? How going to doing so many data flowing in because the cycle is the same, right? You want a higher cycle, you need a very big effort to come down the heat. May happen. Okay, so right now, and in order to do that, you require a wide bandwidth, which data can go faster. How you do that? The only way now to make a solution is making your data bandwidth bigger. In any moment, you transfer more data in the CPU that then processing, which means that gradually, right now, everybody have a PC, 8 mega, 16 mega. But the next server require hundreds giga, so that data flow can go faster and faster. Our CPU is able to process more data, but we need more memory can perform this. This is very important. So next, for everybody, have your own AI solution. You need the three things. First of all, affordable cost. Things like NVIDIA stuff, only the company, institute, person have no way. Of course, you can access, but you have to pay. Okay. Secondly, you want a low power consumption because you don't want when you process so many data, it's overheat. Third, you need a affordable and high bandwidth. You can transfer more data simultaneously. That's what's going to happen. Okay. Right now, the computing power, you use NVIDIA stuff like that. You have a very high data processing. For personal use, we have to come down to lower data processing. That's exactly what I'm talking today. Affordable AI chip. Okay. This one first, you need advanced nodes to do that, and all the model parameters scale up from few megabyte to terabyte. Okay. Now you need more money. AI in the high end means money. We will show you the picture. You use more AI, you pay more money because of computing power. That was the day one IBM is charging on computing power. The same situation. It's 100 times, a million times faster. Third, AI computing is consuming more energy for megawatt to gigawatt. If I look at this, you can see this going on. The world GP3, 170 billion parameter. Looking the consumption to go higher. So we have to pay a lot of things for using right now data processing AI. It's costs everybody a lot of money if you use, and the charge, the whole thing is based on the per bit. Okay. That's very expensive. I mean, the big company is looking for charge you the money where you're going to use all the time. Okay. Right now, everybody give you free. That's Apple give you free. But now you used to how to use this, they're going to charge you money. And the more database you use, the more money you're going to pay. That's because the cost structure cannot. Okay. Everybody think in semiconductor, Moore's law slow down because Moore's law means that every 18 months we double the transistor. but it's no longer true. You come down here, you slow down. But the data processing, TSMC invests 5 nanometer, 3 nanometer, 2 nanometer, 1 nanometer. That's cost so much money. Why 2 nanometer? Because you want the low power consumption, fast movement. But it's only for big scale, big server. For average people, you cannot use that. You can only use the server up, but to the big company who buy the server, serve you, they're going to charge you. Okay. That's this picture is showing that TSMC, everybody listen to 2 nanometer, 5 nanometer, 2 nanometer, 3 nanometer. Cost is horrendous high. However, every generation you cost so much money, but the result is not cost efficiency. Even worse. I mean, everybody. Let me tell you an example. If you want to tape up a 5 nanometer wafer, just tape up $30 million US. One tape up, not to make wafer. So this is so expensive for everybody. Your own AI, you must find a solution. You cannot afford that kind of cost, right? This is what we are talking about right now. This is eventually everybody have to pay 0.003, 1K, and then 32K context, you can 0.06 per kilo token. This is going to cost you eventually. They have to. Right now, you can free to use, but sooner or later, they're going to ask you to pay money. The most famous is Apple. You start with a give it free. It become use the whole thing. You want to do that? Sorry, you have to pay. This is like a tentative behavior, right? So we took about 32K context, 0.006K token. Then output, this is called input. You tap in, right? You tap out 0.210K token. If that is the number, the more you use your data processing AI, you're going to pay so much money. This is going to change because every day you use your handset, okay, you use your notebook, your desktop, you don't pay nothing. But this is not going to be the case. You have to pay, right? If you use Google, you don't have to pay. But when you use a charter GTP, eventually you have to pay. Right now, it's just a thing. It's going to cost everybody. AI is going to cost everybody a lot of money. So eventually, this is why keep feeding me ML performance refined model. It's like that. Then you start to pay a lot of money. So we are going to find a solution for everybody on AI. The standard will be affordable cost. The one you talk about AI today is you cannot afford. It's so expensive. You can use it, but you still have to pay. But some of the AI chip using your own purpose, you don't have to pay. So first thing we have to lower cost, affordable cost, I would say. You buy, the way I listen to NVIDIA's chair, Mr. Huang, say, a server will cost you $1 million. A PC costs you 1,000, 2,000. So we must find a way that you can use on your own purpose instead of using big database. So first of all, you have affordable. Secondly, you must have a lower power because I/O power consumption is so high. Right now, the biggest problem is power consumption of in and out I/O because you're floating a lot of data. You cannot have I/O. you will reduce the I/O cost you a lot of heat. Okay, and the third, you have the big bandwidth. Big bandwidth means right now your PC is 16, 16 and 32 bit, then 464. But we're talking about 1,000 beyond bit. So which means that you can data flows go faster. Okay, this is three standard: low affordable cost, low power consumption, high bandwidth. This is exactly what we're thinking we are going to look at. Then we see how these things work. Okay, this is so-called 30-bit. Your SoC and your memory. You have a PCB. You have long line. This yellow line is power consumption. Longer you go through the wire, it's going to cost you a fortune. The heat going up. So if you have so many data, it's going to real heat, right? So the second way is to right now everybody know CoWa means that interposer. So interposer can shrink this, okay, the millimeter, so the heat will be much lesser. Okay, everybody hear this interposer, TSMC has a required CoWa, means that interposer, which can reduce the heat consumption, come down. But our proposal, we are now stack. The first one you saw is the stack, which means what means stack? Means that the logic is CPU, MCU, whatever, okay? Stack with memory. So when you stack, first thing happens, you don't have heat because you no longer have these things, right? You don't see any of this, it's stacked together. So first of all, power consumption is extremely low. To conduct such a low power consumption, you need a very, very high-end chip itself, like a TSMC, 2 nanometer, 3 nanometer. But we can have average chip work together because all the you processing computer, one thing, data in, data out, processing, right? In and out. Right now, it's consume a lot of power. And actually, before it's nothing. Right now, everybody, CPU, everybody power consumption is so low. And this I/O is the most power consumption area. Before, we don't worry about that. Right now, this is a problem. When your data goes so fast. But with two things stacked together, you will have no wire. You just in and out data directly. So no heat so very low power, almost no power. Next, if you put memory and the stacked and the CPU stacked together, the other thing going to happen. The bandwidth is no longer, you will no longer worry about 32-bit, 64-bit. Normally, you can go as high as 4,000 bit. So now you have this chip will be only cost no more than $50 or below. So everybody have this chip. You can do it in the AI. Now, when you stick memory and the CPU together, you can make effectively this chip. It's like a single computer. This single computer can perform everything you do. Right now, most of the microprocessor is just microprocessor. Right now, we are evolving microprocessor into an AI computer. You can command anything because it's a computer. You can give your input, guiding everything what you want to do. MCU is not. MCU is just one function you put there. They just perform whatever they ask you, to make air condition, whatever MCU. But right now, for the progress of AI, we can make this chip, and everything you do become AI oriented. So you can control this because you have a computer in the side. Right now, computer is your data input output, but this computer can give you You can give instruction, you put the software, you do whatever you want to do. This is for the next generation AI. You can, it's affordable, it's not so expensive. This AI, I call it operation AI. The one now you're looking, NVIDIA, this kind of server, that's called data AI, which means you input a lot of data, you come out. But the one AI is your AI. You want to, your toy or whatever you want become an AI, because you already have computer inside there. You can instruction whatever you want. Then they become a work for you. This is going to revolutionize everything, because most of the thing you use today has a one MCU, so microprocessor, but it's a microprocessor. It cannot do anything when you fix it in there. But once you become AI chip, now it changed. So you have a right to convert anything, follow your instruction, because it's a computer. So this is the core operation AI, and it's affordable, right? Obviously, NVIDIA, nobody can afford except Institute. It's the company, person that cannot buy AI from the NVIDIA. That's not for you. But the problem is that the structure of NVIDIA, it cannot cost down. It has to stay very expensive, because they ask TSMC making a very expensive chip, they make it even more expensive solution. But they can process a lot of data. And the one I talked about, we are not separate, which means in computer, NVIDIA is a server side, this one is edge side. So right now, within 2 years, we start to revolutionize many things. The previous, when you're making MCU, in the future, it's air computing. It changed. And we hope can bring everything so-called AI belong to your operation. That's exactly what I think we are here to work. Okay, so power chip itself has a memory processing, has a logic processing. So we are the only foundry company now can put things together. TSMC has no memory. So because of we make experience, find this is working. So that's next generation. Because the problem is like this. If we go to the standard TSMC operation, more higher density, like a 2 nanometer, 1 nanometer, but very expensive. I expect 1 nanometer, one tape out will cost you 60 million US dollars, 60, just making one wafer. So not anybody or everybody can afford. The more money because they're going to invest a lot of money in the fab, they have going to charge you very high. So those high end belong to very big company, Intel, NVIDIA, Small guy has no part of it. You just buy the wafer, you just process it. But on the other hand, we are looking for that everybody can find, just like find your PC, find your handset, that you can have some operating AI chip for you to use. And we think they can revolutionize. Of course, data AI, as today, it can do it very good. But they can also do you very bad. You know what? Because you can no longer find the solution, the data come from it's true or untrue. How are you going to differentiate thing come from AI? It's true or false, right? You don't know. You ask, they give you answer. So the good guy can find the good guy's answer. Big guy can find bigger answer is a bad thing. So you have a lot of AI data flowing. How are we going to judge? Some of them are real, some are not real. But do you have ability to differentiate the real or not real, right or wrong? But if you buy the answer, you're going to do that. At the end of the day, you find it's wrong. You don't know. But the personal AI, you can control because that's your stuff. That's what I thought. So anyway, this is the opportunity I like to introduce what happened to personal AI, operating AI, edge AI, but not servos AI. And you can have your solution in many, many ways or improve our life because AI will help many, many things. Because, for example, I think people are getting aged, live longer. If you hire somebody assistant, it's going to cost a lot of money. But you can have AI, robotic, help you in the morning, raise you from the bed, and help you change your clothing. You don't need to ask someone. You can. There will be a robot company leasing you the robot. How long you're going to use? That's called personal AI. We can teach this AI what to do because somebody is higher, somebody lower. You have to raise the people. You have programmed this, and this does not require the kind of AI you ask for data processing. So we need this because we're getting older and the human cost is higher and higher. But you have robot, all you need to charge them. You don't need them to eat. To work. It's going to change. It's going to happen because personal AI. Right now, before all the AI you see, it's not so workable yet. It's a portion of AI. Let me give you a very simple example. See your hand? There's only two things in the world have a hand. It's a monkey, a chimpanzee, this sort of thing, and a human being. You know how difficult to make this? We are thinking about if we have an AI chip, we are making called AI hand. This AI hand is really just like that. You can do that. But you have to have each finger has one computer control. Now, right now, you can. In the future, you can. Then they can help you cook because it's just like a hand. Even this personal AI, one day, surgeon will be only use eyes, not use hand. Hand is by automation, by AI. So it's going to change step by step. And I think it's helped in the economy into a certain range. Because right now, human costs will be higher and higher. Of course, there will be a problem because somebody will have no job. But it's going to help a lot. The country cannot afford. People maybe living older and longer. You need assistance. So we need to use this AI to help our health, for example. The same as medication. So because the AI's mechanism, they will follow instruction one by one, but not our brain. Our brain is so wired. So this is things that I hope that we will come in the next few years, and there will be movement. When you start have a chip, you make your own stuff, do whatever you want to do, and that's exactly what I want to share. The kind of prospect with everybody looking forward to see this going to happen. Okay, so.
Look at this. The furniture has arrived immediately, ladies and gentlemen. Stay with us because we're going to have an exclusive interview. Thank you.
Yes.
If I may, please do take a seat. Thank you. What I really appreciated about your remarks was getting into the technical requirements, but also some vision for the future as well. Now, one thing I've been doing some research is your collaborations internationally as well. And I'd love to get your thoughts, if you would, about your collaborations, particularly with Japan and India. I've seen a couple of announcements on those. Talk to us about why and how.
Let me say it this way, okay? When you move to AI, before you have a notebook, desktop, now your handset. Chip is already indispensable. Your car now become more electric automotive. More and more, you are so depending on the chip available to you to do whatever you want to do. So one of the problem actually every country wide, 75% of the chip is concentrated made in Taiwan. That's not so good. So not only our government and other countries come into Taiwan say, okay, we have to spread manufacture of the chip with other country. For example, Japan, China is doing something. We're now looking for Indian was eagles to do. However, it's a long shot. You need a, for example, country like India. There's a much more problem to do it because you have to choose a place that they have a water, sewage, land,
Mhm.
Transportation, and the location, and where engineer want to live there. So it's orientation, but to make it happen require a lot of effort. But advanced country like United States, like Japan, is much sophisticated. You can do the job, right? But the world, you never know what happened. Now you have a Ukrainian Russian war. Suddenly, I tell you what becomes so severe. Before COVID-19, nobody really aware of such chip making is so important. During the first beginning of the COVID-19, for whatever reason, all the worldwide automotive industry severe shortage of chip. Then I have received Volkswagen, Mercedes-Benz, and can we give a chip?
Mhm.
Automatic chip require a lot of processing before you cannot. We cannot do overnight. So no. So,
And in those circumstances as well.
yeah. So the first thing everybody realize, if we don't have a controller chip, we can't even have a final production. Automotive production is so important in many countries. It's if you don't have this chip, you have to lay off people. You cannot shipping the car. So now, first things people begin that, and they have a more hand-on chip, they cannot do things. The other thing is Ukraine-Russian war. Russian cannot continue strong, military presentation in the world because they have no chip to make the weapon.
Mhm.
They have to make a chip come out from the refrigerator, from air condition, put that. But of course, doesn't work that way.
Mhm.
So now, during war, this timing, every country, it's a European, everybody realized that if we don't control the chip, no way, we ain't gonna survive. So more and more people focusing is a strategic economic need. Um, before that, it's everybody's okay. We can have a chip. The other thing that happened is that people is moving automatic electric car, everything else. Before the $400, $500 per chip per car. Now move to 1,500. Eventually, the electric car rating that's $5,000 chip. Means that electric is predominant, especially when you have an electric car, the engine no longer so important. And this is we have reduced carbon dioxide. Some pollution action replaced by electricity,
Mhm.
but electric means chip. The thing is, we are moving in that kind of direction, environment protection and many things. We have to rely on the performance of chip to make it working better.
Well, I wonder if I could pick up on that because, Dr. Huang, you've talked a lot, and I know that you're very proud of your sustainability efforts. Can you share some insights into, you've just been talking there about driving down sort of processing power and what other things you're doing in terms of the sustainability agenda?
What do you mean by other thing?
In terms of how you're doing business today and how you intend to do business
Okay.
tomorrow.
Evidently, the more economic impact by several things. First of all, inflation, right? Inflation is impact everybody. Secondly, the Ukrainian-Russian war. Every European country is very alert what's going to happen to this war. Third is that the fighting or high-tech dispute between United States and China, which caused a little bit problem with China today. Economy not good. So this is happened in somewhere effect impact on the chip. But my personal belief, by next year the war will be over. That the construction, the revival of Ukrainian will be have a lot of demand on the chip or other related things stuff. There is the Olympic in France, and inflation will coming down. So we're looking forward a better next year. And at the same time, the utilization of AI will be speed up.
Yeah. Yeah.
So we are into two big consumption of chip, AI. Secondly, automotive. These two definitely. Looking at the weather, yesterday I saw that I've never seen that. I was used to United States. There's a huge hurricane in U.S. because all the U.S. hurricanes go down, now go up. The place like in New York, Boston, they never have a hurricane. Now they have a hurricane, which means unless we control the carbon dioxide, the weather will getting worse and worse. And this is something we cannot omit.
So here they're talking about the supply and demand dynamics, the geopolitical climate, and then also some of the environmental factors that are happening as well. Now, the UK-Taiwanese collaboration is incredibly important. I'd love to get your thoughts on how do you see that playing a part in what you're trying to do?
We have at least 2 days with discussion many things is UK. My personal belief, UK has a many talented engineer. Look, yesterday, today's ARM is going to on the market. How to utilize the ability, because UK every now and then get a Nobel Prize, a lot of successful. Only next to United States, UK is the best. UK and Japan is the best country get the Nobel Award, right?
Mhm.
Not Russia, not France, not Germany. So means that you get a lot of talent. You continue this kind of ability in the research, and so how to utilize the clever engineer and person to become involved with the next phase of the chip of the of the AI or system design. This is a good topic to really, if UK government is looking for this series, I think it's going to start to do something correctly.
Incredibly important. And I just wondered, actually, we're going to invite some questions from the audience. If we may, does anybody have a question for Frank? We have a hand at the back. So we're going to bring a microphone to you. Can everybody still hear my head? I've kept my headset on so I can feel what you feel. Really important. We're getting a microphone to you, so we should hear that question coming through.
Yeah, hi. Frank, thanks for your presentation. It's very inspiring.
Can I pause you for 2 seconds? Can you hear the question? By the way, you can. Good. Excellent.
Okay, I'm Ken, so and actually a semi-sector equity analyst at a fund house called RoboCap. So actually, I would like to ask a kind of a basic technical questions. It's because you mentioned about the 3D stacking would be kind of a breakthrough for the development of AI chips. It could lower the cost. But I would like to ask, it's because for 3D stacking, we have been using it in land flash for many years. Nowadays, the land flash has developed to like several hundred layers. But for the mainstream AI chip, for example, those used by NVIDIA, is still on HBM, so-called 2.5D technology. So I would like to know, it's well based on my understanding, there should be some kind of bottleneck or some problems of applying 3D stacking at so-called the SoC for AI chips. So could you share with us what kind of breakthroughs we need to really apply the 3D stacking on SoC? Thanks a lot.
And Dr. Wang, we have a couple of minutes. Thank you.
Although I'm not so totally understand your question is okay, but when you ask and you say AI everything, this is the first step of we move to personal AI. I think in time goes by, there will be, because our problem is that company like TSMC has moved the chip into the more 2 nanometer, 1 nanometer. That's so expensive. It's only can afford to several companies like AMD and NVIDIA. Everybody, average citizen, had nothing to do with this. But we must find some solution for everybody. Today's presentation is just the beginning. I think if some other time we can see more and more. But we cannot rely on the higher resolution. We must find another solution because it's expensive. Average people cannot afford it. Everybody you're looking at, PC and notebook, why it's so popular? Because it's cost of everybody can afford it. right? This is a mass market. We must make everybody can do whatever you want to do, just from desktop, notebook, handset, all the way to next to AI. This is I was in this business 40 years. I start a computer they call portable, called compact, small screen like this.
I had
until
one of
today.
those.
I mean, it is if you're looking, it's a lot nothing, but that time there was the wood.
Was.
So in terms of the science and technology advance, you can never see it. I remember like 1980 something. I was in Germany on a computer show. That time was so big deal because the first notebook use use orange light. That's what plasma. It was crazy. Some more. Look, today's everybody handset. Everybody, it's incredible. And then when the right now which 5G, before 3G, you have to you want to transfer a picture, color picture, from German to Taiwan through that kind of line. Takes 30 minutes to 50 minutes one picture. Right now, everybody boom, move.
Amazing.
So the technology movement is incredible.
Mhm.
If you go through all this, you can do a time and period unbelievable. And 5 years from today, we will talk about, you take a look at, okay, it's just the beginning of AI. Now everybody has all kind of AI. People are so smart. When you give a tour, they start to move everywhere. Okay? So I was concerned there will be, everybody has a more and more data flow into your PC or notebook, in your handset, finally in your brain. How are we going to handle those data processing? That will be the next question. How we handle all this?
The next question, I'm afraid, for another time, because much as you've had hands up and I really appreciate them. Unfortunately, the clock is not our friend this morning. However, I'd just like to take a moment to thank you for being with us. Thank you for your insights on affordable cost, power consumption, bandwidth, thinking about the current state, geopolitical and also production supply.
Thank you. I hope everybody gets some
collaboration.
comprehensive knowledge that what's going on where I move to the next generation or next movement.
Indeed,
Okay,
and some vision for the future.
Thank you.
Ladies and gentlemen, please join me in thanking Dr. Frank Huang. Thank you very much indeed,
you.
sir. Thank you.